Hi. In this video, we're going to take our knowledge of the law of conservation of energy, as well as energy pies and energy equations. We're going to use them to actually solve word problems. So let's look at example number one. Free Fall Freddy is in an elevator. He is going from the ground floor up to the fifth floor. Each floor is 4 meters apart, and Freddy weighs 750 newtons. Okay, so I'm going to draw this scenario really fast, just because it's always easiest to have a visual. So we have Free Fall Freddy here in his elevator, and he is going to go up to the fifth floor. So here he was on the ground floor. And then the fifth floor, but each floor is 4 meters apart. So that tells me that he is now 20 meters up into the air. And Freddy himself weighs 750 newtons. So his FG is 750. Okay, got it. What do they want me to figure out about Freddy? What is Freddy's gravitational energy on the fifth floor? Okay, so gravitational energy, if you recall from 4.2, can be calculated using mg delta y. So his mg, right? mg is the same as fg, so I can just put in 750 for his mg. And then his delta y, well, we talked about it, right? The fact that he goes up to the fifth floor means that he goes up 20 meters. And so he must have 15,000 joules of gravitational energy. Cool. Suppose the elevator cable snaps. What is Freddy's kinetic energy right before he hits the ground? Okay, so Freddy, he's going to start here on the fifth floor and he's going to end up down here back on the ground floor. And I'm going to use energy or conservation of energy, I should say, to solve this problem. When the cable snaps, Freddy is at rest, but he is way high above the ground. So we would expect that all of his energy would be gravitational energy. And when he comes down to the bottom, he's going to have the same number of joules, because that's what the law of conservation of energy says, but we would expect that they would be different. They're no longer going to be gravitational energy because he's back on the ground. And we're looking at the millimoment before he hits the ground, so I believe he will be still moving. So all of his energy has now become kinetic energy. And so with these pies are telling me that his gravitational energy is equal to his kinetic energy. So since I have already calculated that his gravitational energy at the beginning, right here, was 15,000 joules, then I know that his kinetic energy right before he hits the ground must also be 15,000 joules. Now, part C asks, what is Freddy's velocity right before he hits the ground? Okay, well, since I know that kinetic energy is equal to 1/2 mv squared, I should be able to find this velocity because I can put in 15,000 joules as my kinetic energy. Oh, mass. Okay, I know his mass indirectly. Because if his FG is 750, I can take 750 and divide it by 9.8 meters per second squared, right? Because FG equals mg. So I'm taking the FG, I'm dividing it by g in order to get the m. And so that should leave only his velocity as my unknown. And so now I can punch this into my calculator and solve. And to save you all the pain of having to watch me enter things into a calculator, I'll let you know that my calculator told me 19.8 meters per second. So that's how fast he hits the ground, which is really fast. Oh my God, I would not want to be in Freddy's position. I don't think Freddy's going to make it. I think he's going to have a really tough time. Oof. Moving almost 20 meters per second by the time he hits the ground. Oof. Okay, let's look at example number 2. A car is being loaded onto a truck by pulling it up a plank inclined at 20 degrees above the ground. The plank has a length of 6 meters and the car has a mass of 1,500 kilograms. Okay, I need to draw a picture of this. That was a lot of information. Okay. So I should draw my plank. Okay. So it's 20 degrees above the ground. So this right here is 20 degrees, that angle. The plank has a length of 6 meters. So this length is 6 meters. What am I pulling up? I'm pulling up a car. I'm pulling up a car. Okay, and the car has a mass of 1,500 kilograms. 1,500 kilograms. Okay. So, what is the increase in the car's gravitational energy? Well, that at least is fairly straightforward. If I want to calculate the car's gravitational energy, I can just do that by doing mg delta y. So, the car's mass is 1,500 kilograms. G is 9.8 meters per second squared. And my delta y, oh dang. If I look at my picture, I am not told the number for delta y. However, I can use my knowledge of trig to figure it out, right? Because I do know that this is the opposite side. So if I use sine of 20 degrees, that should equal the opposite side of my triangle, delta y, divided by the hypotenuse of my triangle, which we know is 6 meters. So 6 times the sine of 20 should tell me what my delta y is. And I'm just going to write that right here. And again, to save you guys the pain of having to watch me type numbers into a calculator, I'm just going to tell you that my calculator gave me a gravitational energy of 30,166 joules. Nice. Okay. Part B, how much energy is lost to friction, heat, and sound if it takes 90,000 joules to get the car to the top of the ramp? Ooh, okay. So I am going to think about this by using a pie. This is why we love the pies. Now here's the deal. I know that this entire pie has to equal 90,000 joules, okay? Because that's what they're trying to tell me right here. It takes 90,000 joules to get the car to the top. So that's how big this pie is. So what is inside of that pie? Well, we definitely know that some of the pie, that was a terrible line. Some of the pie is gravitational energy, right? At least 30,000 joules of it, for sure. What else would be in there? Well, probably some energy loss to heat, light, and sound, considering that's what they're asking me to find. And we know that energy loss to heat, light, and sound is thermal energy. So our total energy, which I'm just going to call E, well, I guess I'll call it E total. Right? The entirety of this pie has to be made up of gravitational energy and thermal energy. So since I know my entire pie is 90,000 joules, I know my gravitational energy is 30,166 joules. Well, then I should be able to figure out how much of my energy is thermal energy by doing 90,000 minus 30,166. And again, to save you the pain of watching me type in a calculator, I'll tell you that my calculator gave me 59,834 joules. All right. I hope you find energy pies useful. They're really helpful, I promise. Thanks, guys.